Welcome to the European Southern Observatory. In this video, we will introduce how to prepare gravity observations. Gravity is a 4-telescope beam combiner installed at the Very Large Telescope Interferometer, or VLTI, operating in the near-infrared K-band from 1.98 to 2.40 micrometers. Gravity is designed to provide extremely high angular resolution information, achieving a spatial resolution that can reach 2 milliarseconds. It is particularly utilized for precise narrow-angle astrometry and phase-referenced imaging of faint targets. The instrument works by coherently combining light from 4 telescopes, which can be either the 8.2-meter unit telescopes, or UTs, or the 1.8-meter auxiliary telescopes, or ATs. Gravity consists of 2 independent interferometers operating simultaneously: the fringe tracker, or FT, and the science channel, or SC. The fringe tracker analyzes the fringe pattern of a target star at a high frequency, approximately 1 kHz. It uses this information in real time to correct for atmospheric turbulence effects and stabilize the fringes of the science channel. All gravity science observations are always assisted by fringe tracker observations, and the fringe tracker spectrometer always operates at low spectral resolution of 22. The science channel records the spectrally dispersed interference fringes across the K-band. This channel benefits from the stability provided by the fringe tracker, allowing for long exposures. The science spectrometer offers 3 distinct spectral resolutions: low of 22, medium of 500, and high of 4000. Gravity simultaneously measures 6 square visibilities and 4 closure phase values. The squared visibilities measure the spatial extent of a target along the projected baseline. The closure phase is a robust quantity, largely independent of atmospheric perturbations, used to investigate asymmetry or detect high-contrast companions in the source geometry. Moreover, when the fringe tracker reference star is distinct from the science target, gravity also provides a direct measurement of the science target's phase in reference to the fringe tracker target. This quantity constitutes a direct measurement of the differential astrometry between the 2 targets, thus allowing for accurate astrometric measurements. Gravity can combine the light from a single source or 2 sources simultaneously, offering several observing modes. First, single field mode on axis. The light from the target is split equally between the fringe tracker and science channels, and the science target itself is used for fringe tracking. Second, single field mode off axis. The science fiber is placed on the sky, and all the light from the science target is sent to the fringe tracker. Although this mode is not commonly used, as it delivers only the low resolution data from the fringe tracker, it increases the limiting magnitude by 0.5 magnitudes compared to the single field on axis mode in low spectral resolution. Third, the dual field mode on axis. The light is split in a similar fashion as for the single field on axis mode. While the fringe tracker fiber tracks the fringes on a bright object, the science fiber can be offset by small separations to observe possibly much fainter objects. The maximum separation between the SC and fringe tracker fiber is 0.6 arcseconds on the UTs and 2.7 arcseconds on the ATs. Fourth, the dual field mode off axis. This mode is similar in essence to the dual field on axis mode, with the exception that the offsets can be larger and that there is a minimum separation between the fringe tracker and science channel, meaning that the calibration plan must be adapted. One benefit is that the light injection is more performant, where 100% of the light is injected in each channel compared to the 50-50% of the on-axis mode. The maximum separation between the 2 objects is limited by the VLTI field of view, 2 arcseconds for UTs and 4 arcseconds for ATs. And lastly, the dual field wide mode. This mode extends the separation limit by using the VLTI star separators. The maximum separation is significantly larger, up to 30 arcseconds for both UTs and ATs. Due to atmospheric effects with increased separation, this mode currently only provides relative measures, differential visibilities and phases, and absolute calibrations are not offered. Once your gravity proposal is accepted, you can move to the ESO Phase 2 tool for preparing your observing material. In the Phase 2, you can define your observing blocks, or OBs, which specify the details of your observations. If you are not familiar with the Phase 2 tool, we have a dedicated video about it in this channel. See link in the description. You can use the Gravity Exposure Time Calculator, or ETC, for visibility calculations and their feasibility. Each OB shall include a target acquisition template and, typically, one science template. The acquisition template must be the first template in an OB and is responsible for pointing the telescope, setting up the VLTI and instrument components, injecting the target light into the fibers, and successfully searching for and tracking fringes. Gravity uses several distinct acquisition templates corresponding to the field configurations. 5 standard modes: single on and off axis, dual on and off axis, and dual wide, and 1 dither template, only offered in visitor mode. Following successful acquisition, the observing templates are used to record the required science and sky data. These observing templates allow to define the sequence of exposures, typically combining object and off-source sky observations, and setting parameters like the detector integration time, the DIT, and the number of frames, the NDIT. Gravity Dual Field Mode, both on-axis and off-axis, also offers a swapping template. This swaps the fringe tracking and science objects by rotating the field by 180 degrees by using the Gravity D-Rotator. This template can be used for normal science observations if you wish to observe both dual field objects with a spectral resolution, for example binary stars or YSOs. In this case, the template avoids using a full acquisition and saves observing time. This template is also used for astrometry to obtain an independent metrology zero. For Gravity OBs, the target information placed in the main target tab varies depending on the observing mode selected. In single field mode and in the standard dual field mode, the coordinates provided in the target field must be those of the fringe tracking object. For the dual field wide mode, the science target object's coordinates are instead placed in the OB target tab. The information for the fringe tracker source in this mode is defined using specific keywords located directly within the Gravity Dual Wide Acquisition template. When absolute calibration of the visibilities is required, you should also prepare OBs for appropriate calibrator stars, chosen in terms of target proximity, magnitude, and apparent diameter. For dual field wide mode, no absolute calibration is at the moment possible, and therefore calibrators are not needed. Depending on the science case, any sequence of science and calibration observations are possible, with the different OBs being grouped in a concatenation. More specifically, this means the following sequences are possible: science only, when no absolute calibration of the visibilities is required or possible, for example, always in the dual field wide mode, or in astrometric measurements where the two sources are swapped; calibration science, science calibration, science calibration science, or calibration science calibration. Before finalizing your Phase 2, please ensure you meet all the general and instrument-specific requirements. This includes providing finding charts, integration times and offsets, setting the correct fringe tracker parameters, Coude guide stars, and baseline configurations. Once your OBs are reviewed and approved by your assigned support astronomer, your observations will be scheduled for observation at Paranal Observatory. Once the data are taken, raw data is placed in the ESO Archive and it is immediately available to the users, although they become public only after the corresponding proprietary time. Thank you for watching. More information can be found in the Gravity User Manual and associated online documentation. For any questions, please contact us at ESO User Support. Happy observing!